Okay, everybody. I want to say good morning to you guys. I hope you guys slept well. I'm gonna fix this microphone. Um, yeah, sorry about that. Okay, we're gonna fix this microphone here so you guys can hear me. Um, Maybe that's okay. Yeah, that looks like it might be okay. Okay. All right. So good morning to you. As you guys know, we will be having, if we go to the browser, let's go to the browser here. Okay, let's get to where we need to go. So let's go to the browser, and we're at the browser, and we say, okay, let's find Math 227, and we're looking at our schedule, and you guys can see something here. Test 3 is going to be on Monday, May 4th. That's when test 3 is going to be here. Monday, May 4th. So hopefully you guys are, what shall we say, been doing what you're supposed to be doing because, that's important for your test. And I want to remark also, too, you guys really need to do a couple of other things. Make sure you are okay with how to upload your exam, meaning you have a scanning app that can PDF and upload your test. Now, you guys had already an experience once doing this. So the idea is that you learn from that experience, hopefully, because this time around, what's going to happen is you're going to be timed like you were last time. And there's going to be less flexibility. So make sure you set your clocks, even your phones or whatever, that can keep track of time on the test. Because once the test is over, you have a short window to turn it in, right? You're going to have a window to turn it in. So the test will stop, and then you got to turn in your test. The test isn't over when you decide it's over. You guys know that. It's not when you're done if you're done. You say, Mr. Judge, I need 3 days to even try this because I have to study. Well, you should have done that ahead of time. So if you run out of time, make sure I'm not going to take your test if you don't upload it in that window. So make sure you guys really know what's going on, meaning you can use your scanning software on your app because you can take a picture of your test and your work. You're gonna upload it to the appropriate place. So I'll be giving you guys some instructions about that. Follow the instructions. It's going to be reading. You guys are college students. This is what this is about. It's about adapting to your environment. And that's what's going to be the difference between people that move forward and people that don't, the adaptation. So make sure you guys know about your scanning app situation. Set your clocks for your test time so that when you run out of time, you're going to have a short window now to upload your completed exam. Okay? So that's kind of how things are going. So you already had some experience. That's the idea. You're moving toward a more functional sort of way to do things. And ladies and gentlemen, that's what's going on here. So make sure you're ready for Monday, May 4th. Now, sometimes people say, hey, Mr. Judge, are you going to put a practice exam? The answer is yes. I'll put that up this weekend. Now, stop and think about the essence, or I should say, what is the purpose? You're supposed to be doing homework. This is where you study. The practice exam or a study guide, whatever you want to call it, isn't something where you say, oh, can I now see the solutions too because I don't know what I'm doing? Well, by then it's kind of too late. If you want homework that has solutions, look at the notes, look at the, if you want to see questions that have solutions, look at the notes, look at your textbook. They're there. So that's how you do this. This is how you function. Remember, if you make things so you hand everything and spoon feed people every little detail, they don't learn. They don't move forward. And that's the problem. So you want to learn and move forward, which means, no, I'll put the study guide, but no, there's no solutions type of thing. You guys know the deal. So nothing's changed and nothing's different than what we've been doing. So that's what's going on. And also, I got to say, tomorrow I have a doctor's appointment, so class will be canceled tomorrow. So I know some of you guys are starting to show up today because I got a test, so I'm going to show up. Well, the people that show up for the first time tomorrow are going to discover, Mr. Judge probably isn't going to have class. You guys will double check. I'll send you an announcement. I got to see my doctor's appointment. Doctor wants to bring me in. So I'm letting you guys know everything now. And again, those who are watching the video later, hopefully they get this information. I'll put it in writing, but if they don't, well, hey, that's the way things go. So anyway, let's go to the lecture. And today, what we're working on, ladies and gentlemen, we started working on really what's known as 6.2. It's really the applications of the normal distribution. So I gave you homework on 6.1, and this is some of the work we did, right? This is all the work we did in that video. And I will put up some additional examples, but what we're going to do today is we're going to work backwards on this. You say work backwards. We want to work backwards now. And working backwards looks like this, so you guys know. They're going to ask you a question that looks like this. They're going to say, okay, example. Like yesterday, IQ scores or normally distributed. And they have a mean that we seen yesterday of 100 and a standard deviation of 15. Okay? All right. Now, again, let's go through this. They're saying IQ scores. Remember that? IQ scores. Oh, got to get rid of this here. IQ scores here are normally distributed. And that's what they're telling me. So if they say that, oh, then I know right away. Because remember, X, which equals an IQ score, that's the value, right? Behaves like a bell-shaped curve. The bell-shaped curve, IQ scores. So you go, oh, okay, the standard picture here then will be the center is that mean. You guys remember? Here's your picture. The mean mu for this distribution is 100 and sigma is 15. That's the standard deviation. Now, I know that because mean 100, standard deviation 15. I know this because they told me. So yeah, you read it and you go, oh, okay, they're telling me everything I need to know for this. Now, this is going to be important. I want you guys to know that there are people in this world that are pretty smart. And what I mean by that, there's a location here. There's an IQ score. We don't know what it is. That's going to separate, ladies and gentlemen, I should say, this group of people from everyone else. I'm saying here, there are people who are geniuses. So you're a genius if you have at the very least a certain IQ. Now I'm going to tell you what that is. That's the top 4% of IQ scores. So what they're saying is that this area for this right tail is actually 4%. All right, you guys okay with that? Now, there's going to be a couple of ways we can do this. Here's going to be our question today. Now put it in red. Well, we don't have, yeah. What IQ score do you need to be considered a genius? So you want to be considered a genius. What IQ score do you need? The top 4%. So here's what's going to happen here. in the past, they didn't ask you this kind of question. In the past, they said what percent of the bow or what probability. Now they're giving you the percent of the bow that's shaded. They're saying this is 4% right in here. They're asking now for an X value. This is why I say you work backwards. This is how this really works. You see, remember the Z formula. Z is X minus mu over sigma. If you solve for X using algebra, you're going to get another formula. So multiply both sides by sigma. Okay, you'll get sigma Z. Sigma cancels here is X minus mu. You add mu to both sides. And ladies and gentlemen, solving for X, we get X equals mu plus Z times sigma. And sometimes people write this as, and I write it as X plus, mu sigma times Z. So in your formula sheet, you'll see that this is called the backwards formula. So it's the backwards formula. But in this case, since the mean is 100, standard deviation is 15, for us, the backwards formula becomes specifically X is 100 plus 15Z. This is the formula that we use to answer all of those questions. All the backwards questions. You say, how do I know I have a backwards question? They're going to say to you, what score do you need or what value of X corresponds to a percent? They're not asking what percent of the bow is shaded. They're not saying what percent of the population. They give you percent. You now need this value of X. Now, if you notice, and look careful here, X is found, this value here, by having knowledge of Z. It's kind of weird. The default, it goes back and forth. Having knowledge of Z. What that means is, if you give me a Z value, you have to find what is Z. You give me a Z value, I'm giving you an X value. So I need this number. That's the key. The backwards formula I use, here it is in general, but in particular, it's right here. So every time you do a backwards question like that, you actually have to use this format. So the real question you guys have to answer, though, is what is Z? Now, if you say, Mr. Judge, Z, we've seen, is represented on the Z table. It's the standard normal distribution. That's right. We've been talking about that. So if I get a Z value, ladies and gentlemen, I can plug it in my backwards formula, and then I get my X value, and I can find the IQ score that's needed to be a genius, to be in the top 4%. So this is an important detail, working backwards. And it's actually going to be kind of the basis of what we do in the future too. So I want you guys to think about that, right? So we're going to work backwards. Now, this isn't so hard to do because I'm going to express to you guys how you do this. Here's the key. If the right tail is 4%, let's see who can answer this question. Let's see who's awake. Let's see if you guys can answer. Right? What here? What percent of the bow is missing? Anybody know?
I got a bad feeling about this.
So what percent of the bow there do you guys think is missing? Because this is the key to answering these questions.
I got a bad feeling about this.
Anybody have an idea there? You have 4% in the right tail. What percent is missing? I'll say it again. Thank you, Jessica. Thank you so much. Jessica says it's 46%. Joanna says it's 46%. And you guys know, you guys are correct. That's 46%. 46% of the bow there is missing in this right tail. Thank you, Jackie. Thank you, you guys. You guys are getting the right answers. This is how you do this, ladies and gentlemen. So we're going to have to think about that. Now you might say, why are you asking for that 46 from 0 to Z? Well, we're going to have to go to our Z table. See, ladies and gentlemen, if I know 46% of that bow is missing, isn't that what my Z table is used for? Any 0 to Z, any value here, 0 to Z, that's what my Z table is good for. So I'm going to have to go to the Z table now. I have to go now, find the right worksheet. That's calculus. That's not you guys. At least not yet. We're going to go and get out of the calculus folder. Let's go to the statistics lecture note folder, and let's go to normal distribution. And kind of done. I guess we have to go to, it's kind of weird, information open. We got to go to our trusty Z table and work backwards. So as this is kind of waking up, let me remark here. This is what you're doing, okay, so you guys know. I'm going to draw a picture. We're going to go to that Z table. Here's the essence of it. 0 to Z is what you use that Z table for, if you guys know. In our case, this is 0.4600 because this represents 46% of the bow. So as that wakes up, what we'll end up looking for is this portion here. We need to find a row, remember that? A column value that corresponds to that missing percent of the bow, the 46%. This is what we're looking for because that Z value will be what we use right here. This is what we really need, the Z value there. So we're looking for this. So hopefully, we can go all the way down again. I guess it goes, yeah, if I try to. Anyway, go all the way down to our Z table. I might be able to import that. There we go. Here's the Z table we're looking for. So everything we're doing here the other day, yesterday, let's get rid of this. We're looking for 46%. So I'm going to have you guys look at your table and try to find 46% here. Okay, we got to take a close look, looking for 46%. And I see something here. Let me show you what I find here. What I see is not 46%. I see 45.99. Now that's the closest number we have here to 46%. That's the closest. Remember, we're working backwards. That's the key phrase today, backwards. Now, how do I know 45.99 is close? Because if this were money, 46% is 46% is like $46, $46.00 on a receipt. 45.99 is, which is what you're looking at as a percent. Well, that's 1 penny off. Okay, $45.99. So the question is going to be, what z-score is associated with that? And I look at the row, I find row 1.7. I look at the column, I find 0.5. So look at this here a little bit closer here. Here's the row it's in, 1.7. And then here's the column it's in, 0.5. So together, that's 1.75. Ladies and gentlemen, that's the z-score we need, 1.75. So in this case, Joanna is correct. So this number is 1.75. And ladies and gentlemen, we can now answer the question. You see, this number goes right in here, my backwards formula. It goes 1.75. So, if I write the answer over here to the left now, let's kind of move. We say, is this x going to be equal to 100 plus 15 times, what was that value for z? 1.75. Now I'm going to approximate this to the nearest whole number today. Let's go to the TI now. You say, okay, TI. There we go. We need 100 now plus 15 times 1.75. Okay, and you hit enter, and you get 126.25. And it looks like that might even be exact. So I'm going to put equal, right? 126.25. I mean, that's the answer. But, you know, if it comes up tonight over dinner, approximating to the nearest whole number, you don't tell people really, hey, guess what? You know what? If your IQ score is 126.25, I mean, that's technically correct, then you can be considered a genius. So you have to have an IQ score that's at least this value, 126.25. And, you know, it starts to become, this is an approximation issue. I would just say it's about 126. So if your IQ score is 126, ladies and gentlemen, you can be considered a genius. And you go back to the original bow. This is what I want to put down. I'm going to erase this value of x because this is what we're finding, right? The z value, we already talked about. That's 1.75. However, the x value that you're looking for is approximately 126. So I put that here. So ladies and gentlemen, anybody that has an IQ score, let's get rid of this. It's not, it's kind of funny. Whatever, we'll keep it that way. Anybody with an IQ score of 126, notice that's above the mean. You're considered a genius. So this is how we handle this situation. Okay? So anyway, this is the IQ score you need to be considered that genius. Anybody have an IQ that's at least 126, meaning 126 or more? You guys know what I'm talking about? Anybody have that IQ? Okay, Sandra has a good question here. Now, I'm not sure what you mean about your question. Why 126? Well, the answer to that is because if you approximated this to the whole number, it's about 126. The exact answer is 126.25. That's the exact answer. Okay? Now, you can use that. Either would be fine, but, you know, you'll see exact answers, and some of them will be approximate. I'm just keeping this in context for you so that when you have dinner and you talk to your family and you say, what'd you learn today? Well, I learned how to compute, finding the IQ score of somebody who's considered a genius, and the definition is someone that has an IQ that's in the top 4%. Then you're considered a genius. And in fact, let's say something else to you guys. There is something a bit better than being a genius. Let's ask you guys this question. there's an even more exclusive group. Let me go back and erase, or let's go right over. Even more exclusive. Meaning there is an IQ score that now in black here. You're in the top 2%. Oops, yeah. There's a special group, ladies and gentlemen, that's in the top 2%. It's even more exclusive than being a genius, meaning you have to have a higher IQ to be in this group. Top 4% is the genius. Okay? Top 4% is a genius. What about top 2%? Anybody know the name of that group? You could be in a more exclusive group here. So I'm going to draw the picture. Since our setting was IQ scores, the center is at 100. That's the mean. We want to know. See this portion here? We're going to find an IQ score. That's going to be our question. What IQ score is in or represents, starts to represent as a minimum, the top 2%? Because if you're in that group, believe it or not, top 2%, if you're in that group, ladies and gentlemen, you're in a very, very special, very, very special situation. Okay, I see some questions here. Cassandra, we're going to answer that question with this question. And we're going to say, Cassandra, no, it's not 50 minus 1.275. The number 50 represents percent of the bow. The 1.75 represents a Z value, okay? It's inconsistent. You can only subtract percent, so they have to both be percents, okay? So 1.75 is a Z value, 50% is a percent. 46 came because, where did 46 come? 4%, it's 50 minus 4%. That gave you the 46%, Cassandra. Okay. Now, this is a different question, though. So let's ask Cassandra this question, or some of you guys here, right? Let's get rid of this. What percent is missing? Because we have a special group. I haven't even told you what that group is. I'm waiting for you guys to tell me. So what percent is missing? If we're talking top 2%, this very special group, I have two questions on the board. What percent is missing? And I want to know what group is so special, has a higher IQ score requirement to get in. It's higher than a genius. It's like the geniuses of the geniuses. Geniuses of the geniuses. Does anybody happen to know what IQ score do you need to get into this special group? What's the name of the group? Anybody know the name of the group? The group is known as, ladies and gentlemen, the group is known as Mensa. I know. Okay, what's the name of the group? Mensa. I know, you guys are going to laugh. Mensa, ladies and gentlemen. Mensa actually is an acronym. I'm going to look it up right now for you guys. Mensa is an acronym, okay? And let's go to the browser. What is it? IQ test. Mensa online dates. What is that? Mensa online dates. Yeah, these guys, maybe they date each other. Mensa International. You guys, oh, look at this. I mean, I'm not saying Wikipedia is completely accurate at all, but whatever. Mensa, ladies and gentlemen, is the largest and oldest high IQ society in the world. It's a nonprofit organization open to people who score at the 98th percentile. Oh, we're going to talk about that. Or higher on standardized supervised IQ testing. Yes. Wow, Mensa. So Mensa is actually a group of super smart people, geniuses of the geniuses. And these are people that have IQ scores. Notice I'm going to compare the language to what we're doing here. I say this is the top 4%. So, as you guys know, what's missing is found by taking 50%. Subtracting that 2%, what's missing here is 48%. So 48% of the ballot is missing, ladies and gentlemen. That is right in here. So I can write it here. Let me write it in. And the reason you care about this, like I said, is because of the fact that when you work backwards, right? In this case, our backwards formula is X equals, yes, it's mu plus sigma z. That's the backwards formula. But for us, mu is 100 and sigma is 15. In this example, if you change the example, you change the mu, you change your sigma. So, like we did before, if we need, and we do, to find that IQ score, the value of X, you need to find what Z is. So you need to answer. What is that Z value? Okay, what's Z? Well, Z again is the picture associated with your situation again. So remember, the Z table works from 0 to a positive Z value. So what you're going to do again is you're going to work backwards. You're going to go to the Z table and you say, here's my Z table again. And instead of finding 46%, in this example, you need 48%. So you need to find what Z score, which row, and which column is 48% found. That's the Z value. If I find Z, I plug it in here, and I get my X value, and we work backwards. We find the IQ score that gets us into Mensa. All right, so we want to get into Mensa. It's the top 2% of IQs. So we're going to have to go back and find our table again. And good. Let's see if we can find this. I'm going to have to erase some things here, though. Okay, so I'm looking for, again, remember what I'm looking for. I'm looking for 48%. And you may not find it exactly. And I'm going to look, and I'm going to look, and I'm going to say, okay, I do see some numbers here that sound interesting. I see some numbers. Well, again, what am I looking for? 48%. You say, how did I get 48? 50% minus 2% is 48, right? The top 2% minus that 50, because our Z value works for what? This picture I have up here, it's still here. From 0 to that number. But in this setting, this is 48%, which is 0.4800. So look at the Z table and try to find, is there anywhere on the Z table? Is there anywhere on that Z table that's 48%? So you're looking at your Z table, and yes, on your test, you're going to have a Z table. And you go, okay, let's find this 48%. Okay, here's our Z table, I guess. Where are we at? Here we go. No, that's not it. Yeah, looking for the Z table. So let's see what you guys have, 48%. I'm looking at this table and I see 4798 and 4803. $4,798. So maybe we should write this down here. All right, here's what I want to show you guys. So we need that table here. I want to say, what Z values do you guys see between those two that's closest to the 48%? You kind of have a problem here. There is one value that's closest. You could use it. Let me point it out to you. But there is another value. Here we are. So it's saying looking for 48%. I'll find it here. We're going to see these two values here. See, ladies and gentlemen, it's between these two numbers because this is $47.98, $48.03. We're trying to find the value that's closest to 48. Now, I think Joanna has the right idea. Let's find out. What row is that in? Row 2. Which column is that in? 05. So that's in row 2, 05 column. Okay, now that's closest. And so you said, okay, this is 2.05, and you're right. So this is row 2. This is in column 0.05. So we could use that number. We can say 2.05. However, if I look at this next number, actually, which is 0.06, I can do slightly better. See, because 48% is approximately midway between 47.98 and 48.03. So it's approximately midway. So I can do an even better approximation. I have to find use a Z value here that's midway. Between 2.05 and 2.06. What number's midway between these two? Okay, so you say, oh, I can find, because 48 is between these two numbers. 0.4800 is between 0.4798 and 4803. So you can say, can I take the 2.05 and the 2.06? Can I add and divide by 2? And the answer is yes, you get 2.055. So we can get a bit better by finding the midway value, the midway between these two Z values, because of the fact that 48% is actually between two numbers, 4798 and 4803. What's approximately midway? This will give us a slightly better, by the way, slightly better approximation. Now, you may say that might be more trouble than it's kind of worth. Well, maybe, since we approximate at the end, right? You're going to say, let's see what the difference is. 2.055 versus 2.05. We're going to find that what the TI says. Let's see the difference, if it's such a important difference. So let's see. Okay. 100 plus 15 times 2.05, we get, when it's 2.05, we get 130.75. Okay. 100 plus 15 times 2.055. So notice the difference. It's slightly different. All right. It's slightly different. So if I go with the 2.055, I have 130.825. And yes, that's approximately 131. So notice that kind of makes some sense. The reason it makes sense is because of the fact that this is bigger, larger value, larger IQ score than being a genius. And that's what it should be because it's more exclusive. So this is about 131. So if you want to be a member of Mensa, okay? Sorry. If you want to be a member of Mensa, you need an IQ score that's at least 131. And ladies and gentlemen, that'll get you membership into the Mensa group. It's an IQ score that's in the top 2%. Compare that to the top 4%. In the last example, you need an IQ that's 126. That's less exclusive. So yeah, a little bit higher. 131, ladies and gentlemen, you could become a member of Mensa. Now, this is a super smart group. All right. Now, some of you guys are going to say to me, Mr. Judge, I have a TI, and is there any way I can do this with a TI? The answer is yes. You can do this with a TI. So let me show you guys. But if you're going to do this with a TI, you're going to have to know some information. Here's what you need to know. Even though they asked you a question, and I'm going to do this. They asked you a question. What IQ score is in the top, meaning above the mean, top 2%? Anything above the mean is called top. I want you guys to answer this question here. What percent of the bell is in gray? In other words, what's the complement of the top 2%? Right? What's the complement of the top 2% now? This is what's going to be in gray here. Right? Because you need to know this if you're going to use the TI. I need to know what percent of the bell is what percent of the bell is not shaded is the question. And that's the whole thing that's in gray now. That's not shaded. The top 2% is shaded. So what would you guys do here? Anybody have an idea? How do we use the TI to do that? I mean, what's the answer to this question first before I show you how to use that TI? What do you guys think? What's in gray? If I have 2% of the bell is in this right tail, what about the rest? How do we find the rest? Isn't that 100% minus 2%? Didn't I say the word complement? And that means in gray, ladies and gentlemen, is 98%. And 98% is 0.9800 as a decimal. So, Joanna, you're correct. 98%. Thank you. Let's see the right answers. We got Joanna and we got Jessica. Okay, these are the answers here. We got Erica. You guys are getting the right answers, right? We got Sandra. Now, you say, why do I need to know that that's 98? Well, you need to know that because of the fact that if you want to go to the TI directly now, let's go to the TI. There's a function. Go to the distribution list again. Second vars, which is really blue, DISTR above there. And you're now going to go down to what's called IN, invert normal. To invert is actually go backwards. So you're going to go to the invert norm. Invert norm, ladies and gentlemen. Number 3 in the distribution list. Hit enter. Now, inverse norm, working backwards. Inverse. You have to answer some questions here. What's the area? Ladies and gentlemen, the area here is 0.98, which is 98% as a decimal. So I need to know, and this function only uses area to the left. So in other words, area to the left of that X value. That's why I had to say to you guys, if I try to find where we're at, that's why I had to ask you guys, go to the iPad. This is the area. This is, by the way, in red. We need to find that X value. We already know what it is. This is the area that's to the left of that number, which is 98%. That's what you guys use. So you're going to use the TI. So now you have to tell me, for this example, what was the mean? The mean is 100 because it's IQ scores. Standard deviation is 15. Let's hit enter. And sure enough, ladies and gentlemen, you get again this approximation, 130.806. This is all approximations now. And this is why I said to you guys, let's go to the nearest whole number today. Nearest whole number, 130.8, meaning the 0 is in it's like the ones position when you approximate. The ones, okay? So 130.8 is approximately 131. Right? Let's put 130. Let's go back to the iPad. So the TI is saying X is approximately 130.806. So the nearest whole number, again, is 131, which is exactly what you guys have by working backwards and using the Z table. So if you do have a TI, ladies and gentlemen, you can do this using the inverse norm key. Inverse norm, right? INVNORM. You just need to know the area to the left. And that's why looking at, the shaded bow when we started all this, why that was so important. You got to know, these areas, area to the left of value, area to the right. So top 2% is a right tail. And similarly, if we go to the last example of the what? The genius, let's verify that it's 126. Let's go to the geniuses now. So I'm going to get rid of this portion. Can't get rid of that. Let's go back to the genius example. Let's see if the TI gives us an answer there. This is in the top 2% now. I'm sorry, 4% for geniuses. So yeah, 4%. 4% is there. Now let's see area to the left of this value. Let's see if you guys understand the left, meaning what percent of the bell is in gray here. This is to the left of this. I'm going to erase it. It's to the left of this X value. We're trying to find what that answer is. And let's see, what's the complement now of 4%? Do you guys know the complement of 4%? What's that going to be? Is this whole thing 96%? The answer is what? Yes. So the complement of the original 4% is 96% because the TI only knows area to the left for this special function. So I go to the distribution list, go down to inverse norm. And now we hit 0.96 it has the same mean because it's the same setting, same standard deviation. And again, if we approximate this to the whole number, 126.26 again, okay, 126.26. Oh, we approximate this to the whole number. What do we get? X is approximately 126 to the 26. Yeah, X is approximately 126 again. So this is working backwards, ladies and gentlemen. So in order to be considered a genius, yes, you have to have an IQ score that's at least 126. Now, this is in the top and this is in the bottom. Now, similarly, so you guys know, we got bottom. If I said to you, what about the bottom portions? Like the bottom may be 5%. Or the bottom, yeah, let's do a bottom 10%. Well, I just want you guys to note. Here's something that's good. Let's note. If you know the top 4% and it had a Z value already, so you guys know, if we go back, working backwards, we had a Z value for the top 4%. Z value was right here, 1.275. That was the Z score, if you guys remember. If you know the top, you know the bottom. This is my point. You had 100 here. Oh, that's not so nice. I should say this. Let's put this as a Z score. 0, 1.75. These are Z values. And we know this portion is 4%. That's the top. But what I'm saying to you is, what about the bottom on the other side? See, this is the bottom 4%, where this was the top 4%. See if you're awake. Could you tell me, right in here, what Z score is this if we're talking bottom? Here's my big hint. Use symmetry. Bottom is below the mean. Top is above the mean. Anybody want to tell me? What's that bottom? Well, what's on the other side of 0? What numbers are on the other side? Aren't they negative? So if you know the top value, and the top was positive 1.75, on the other side, it's negative. So if they say what Z score, here's the question, right? What IQ score is in the bottom 4%? You still use your formula, the backwards formula. X is mu plus sigma Z, which is X is 100 plus 15Z. Thank you. You guys are getting that Z value. Negative 1.75. So altogether, if you said X is 100 plus 15 times a negative, I'll put that in red so it stands out, 1.75, what does the X value become? Let's plug that in. $100 plus 15 times, put a parentheses, negative 1.75. You close that, and what do you get? Well, this is exact 73.75, which means this is approximately 74. So if your IQ is approximately 74, ladies and gentlemen, you say, where would that be? That's the bottom 4%. Okay, these are IQ scores again. That's the bottom 4%, right? If your IQ is in that range, I mean, if you're 74% or lower, you're in the bottom 4%. So this is kind of what we've done here. You just plug that in, and yeah, about IQ score is about 74 if it measures that. Okay. Now, if you said, Mr. Judge, does my TI know how to do this? And I'll say yes. Look at this picture I drew. 4% is 0.04, ladies and gentlemen. Remember what the TI does. You need to know area to the what? Left of this desired X value. So assume we don't know it. But I need to know to use the function, the inverse norm function. What I need to know is area to the left of that number. Area to the left. So, okay, let's try inverse norm. Second distribution, go to number 3. Area is, you have to use a decimal representation of 4%. You got to use 0.04. Use the mean and standard deviation values. Hit enter. Isn't this still approximately 74%? I know you're saying, Mr. Judge, that's different though. That's 73.7397. I know. Remember, your Z tables are approximate as well. Your TI is a more accurate version. TI has greater decimal places than 4 decimal places. So it's a bit better. But if we're talking whole number, it's still going to be about 74. So the TI, ladies and gentlemen, still can come through working backwards. You just have to know how to write a percent as a decimal, and you need to know the left area. You need to know your left, because that's how this function works. So this is how we can do things, and this is how you get your answer even in the TI. Anyway. All right, now I'm going to ask you these questions here. I'm going to say, here's my questions to you guys. What IQ score is in the bottom 10%? All right, it's in the bottom 10%. We're going to ask those questions. So I start by drawing a picture like we said yesterday. You say, okay, here's my bell. This is IQ scores. Now, anything that's to the what? Anything that we have is the bottom is to the left of the mean. So, okay. It's an IQ score. What IQ score? Remember, isn't that what we represented this with? X. And now they say bottom 10%. So that means my left tail here is 10%, and 10% as a decimal is 0.10. Okay. So we have a couple of ways we could go about this. Remember, we can use our Z table, but we want to know, if we use a Z table, what are we looking for? What's the Z table good for? Whatever is missing. So if we have 10% in the tail, what's missing there in red? This is using the Z table, and then we're going to see the TI. what's missing in red, ladies and gentlemen, is 40%, because this is what we use the Z table for. So your table now, you say, you need to find a row and column that corresponds to 40%, because this is where the area goes. So say, what row? What column? 40%. So working backwards on that table, here's the table. We're now looking for 40%. So we scan this table. Which is closest to 40%? Anybody know? And Annabelle, no, the area is never negative. It's always positive area. Anybody see what's closest to 40%? I think I see this special number here. Let's see if you guys can find it. I see the only thing that's close to 40%, ladies and gentlemen, is $39.97. $39.97. That's closest to 40. It's not even in between. If it was between, we'd actually take the average again. We'd add and divide by 2, or the midway. So here's $39.97, and that's in row, it's in row 1.2, and it's in column 0.08. 1.28. Okay, 1.28. Now, however, it's not positive. Z values can be negative. Z values can be negative, and if it's to the left of 0, it's going to be a negative. If it's below the mean to the left of 0, right, for all these Z values, then yeah, they're negative. This is why we use symmetry. So you can say, do I still use X is 100 plus 15 times that Z? Yes. And what is Z here? Oh, it's negative 1.28. So X is 100 plus 15 times that negative 1.28. So go to your TI calculator and plug this stuff in, and we can say 100 now plus 15 times negative 1.28. Okay? Hit enter. You get 80.8. And again, to the nearest whole number is about 81. Okay, so if your IQ score is about 81, yes, you can get, or you're in the bottom 10% of IQ scores. So I don't know what that means, but, you're in the bottom 10. Who knows? This is maybe where, I don't know if we should say that. We're going to be politically correct. Oh, my God. I don't know what region you're in. You're in the, whatever. Bottom 10%. We'll just leave it at that. Let's see what the TI says. Do we know the left? In other words, to the left of that value of X is 10%. Because the TI, if we go to TI, we go, okay, TI, let's say distribution, go down to 3 inverse norm. We need to put 0.10 because that's the area to the left of the X value. And mean is 100, standard deviation 15. You guys know. 80 point, approximate this to the whole number again. 80.776. 80.7 is approximately 81 again. So we do get the same answer. It's slightly off because the TI is more accurate. But again, notice we're just saying here is that this score right in here, your IQ score, is going to be 81. And it's kind of interesting because the inverse function that we just use is actually the percentile. So notice, this is the 10th percentile. This is actually P10, ladies and gentlemen. So P10 is what we just found. They can even ask, and this is a common question. What IQ score is in the Q1? Does anybody remember what Q1 is? Isn't Q1 the first quartile? They can ask you, yeah. First quartile, Q1. Q1 is P25. And that's code for the bottom 25%. Because your mean here is still 100. Now, because it's on the bottom, it's to the left, ladies and gentlemen. It's a bottom 25%. They want an IQ score that separates the first quartile value from everyone else. So, this is what we're saying. This special number is P25. Also known as Q1. So we're back to those kind of questions here. So we want to find a value of X, an IQ score. No, it separates the first quartile value, bottom 25%, from everybody else. So I want to show you, why did I use this? Why do I use this P25? Because your TI calculator uses that for the inverse norm key. Let me show you how easy that is. Inverse norm. Go down to 3. Enter. Area to the left. Okay, let's go back to the picture because sometimes people need to see. Isn't this the left area to that X value? Area to the left, right? The answer is yes. So then you'd say, I have the same mean, same standard deviation. Okay. It's also about 80.1. What did we do last time? Oh, wait a minute. I messed up. Second, distribution. Talking too much. Inverse norm. Area to the left isn't 10%. It's 25%. It can't be the same. All right, 25% here. Same mean, because that's the area to the what? Left. Let's double check. This is about to the nearest tenths, ladies and gentlemen. 89.88 is about 90. Is that right? 89.88 and so on. Isn't that about 90 to the nearest whole number? To the nearest ones, right? Look to the digit, add 1. So this value of X, ladies and gentlemen, we're saying X is approximately 90. That's the IQ score you need to be in the 25th percentile, or really the first quartile. I'll put it in black. So your TI does give you a nice answer there, ladies and gentlemen, if you can figure out the area to the left and you know some definitions. Sometimes students ask me this question here. They'll say, Mr. Judge, I'm looking in the book, and they say, what IQ score is in the third quartile? I say to people again, draw a picture of the question. Because I would never dream of doing this without drawing a picture. This is Q3. Because remember the definition of Q3. They're trying to find that value. They're saying, what value of X, what IQ score? That's P75 now. They're all the same things. definition of definition here of P, that P75. So you guys know, if I'm looking at area to the left here now, isn't that to the left? Let's actually write it bigger because I have a lot of area to the left. This whole area is to the left. And this whole area, by the way, is 75% is now to the left. So third quartile is P75. They want to know what IQ score. It's all the same thing. I'm just going to use the TI to show you that inverse function key. So second, distribution, go down to, I think I did something wrong. Clear. Second, distribution, inverse norm, but the area to the left is not 0.25, it is 0.75. 115. And you get 110. And this is approximated to the nearest, ones position our whole number. So this X value is about 110. This is Q3, ladies and gentlemen. I can erase this. Well, anyway, I could keep it all together. That's 110. Yeah, you can't see it. Q3 is 110. So they can ask you these kind of questions as well on your test. And these are the most common homework questions people ask me when working backwards. They're saying, what about these other situations, right? What about third quartile? Well, use that TI if you like, and you can punch that in or work, find the Z values. But either approach is acceptable. So I'm looking at your book now. And I want to say your homework here is going to be (6.2). I'll do 5 to 27 odd. And this is from the book. From the web, if we go back to the browser here, and remember, we still have the Mensa information. Anyway, if we go to the web work, you even have additional information on the web here. So you have statistics lecture 12 that we had on the web. And this is part of your homework, right? So if you said, Mr. Judge, I want to look at some more lecture. Well, you have more lecture. Hit play.
Huh? What do we subtract? What do we subtract it from?
Look at that guy. And you have your homework there. If you get stuck, here's some video solutions here. So you do have resources here to do this. If you said, I want to look at those Z values, Mr. Judge, in more detail, well, you have the resources to do it. All right? And I want to let you guys know that. So this is your homework. Do the book work. Do the web work. And then again, when's your test? Does anybody know? When's the test? When's test 3? Anybody happen to know when test 3 is? It's on what day? Monday, May 4th, regular class time. What do you guys have to do? Make sure you can upload in Canvas. Your homework's going to be due. We're going to get your nice homework due, ladies and gentlemen. I'll give you an announcement as a reminder. And guess what? Yes, homework's going to be, we're going to have our, we're going to have our next test Monday. Okay. Yes, you have a study guide coming. Tried to get that up for Friday, but like I said, you guys have to handle the solution. If you have any questions, you guys can actually see me during the office hours. Sometimes people have those questions. And thank you, all of you guys. Let's see. Thank you, Sandra. Thank you, Jessica, for your answer. Thank you, Cassandra. You have a great day. Let's make sure and hopefully you guys stay safe. Take it easy and work on some homework. And I'll see you guys tomorrow, hopefully. I'll send you an announcement if I can't make it tomorrow because I have a doctor's appointment. But I'll send you an announcement nevertheless. Okay? So still expect class, but wait for the announcement. Thank you guys so much. Thank you, Jonathan. Take it easy.